Okay, so we recently did perimeter, so now we are ready to move on to area. We are going to start with making sure we know the difference between the two. So the perimeter of a figure is the number of units outside the figure, while the area of a figure is the number of square units inside the figure. So we're going to do two examples to show you the difference. So in the first one, we're going to start with perimeter. So we're working with the outside. So I'm going to start with the top. It doesn't matter where you start. And I'm going to count how long it is from here to here. And it's 1, 2, 3, 4, 5. Continuing on the right-hand side, there are 3. On the bottom is another 5. And on the left-hand side is another 3. So think about if you were like walking around this shape, how long it would take you to get all the way around. Now we're going to add all these up. And we get 16. Perimeter is just regular units. And we're going to leave it just like that. If they gave us centimeters or inches, we would use that unit instead. Now for area. Area is the number of square units inside the figure. So we are actually going to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And because these units were squares, we put an exponent of 2 on there to represent units squared. All right, let's do another one to make sure you got it. We'll start with perimeter again on the top. This side has a length of 2. To the right here is another 2. This side here is 1, 2, 3, 4, 5, 6. To the right is this little 1. On the bottom, 1, 2, 3, 4, 5, 6, 7, 8. And the left-hand side is 3. We're going to show that we're adding them all up. And we get 22, again, using the word units. For area, remember we are counting the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these were squares, so we write units squared. So that's the difference between the two. Now these are small examples, and it's not very hard to count the number of squares, but if we had a ton of squares, this is not the way we're going to want to do it. So for the rest of this worksheet, we're going to be using area formulas that are given to us and substituting in values. So here it says, many shapes have area formulas to help us determine the area. Find the area of each shape. So we're going to start with parallelograms. Parallelograms, the area formula is area equals BH. And when they're up against each other, remember that means multiplication. So we're multiplying the base times the height. So I like to write out the formula first. And now we're going to substitute. The base is usually the number along the bottom. So our base is 8. Remember, we're multiplying. I'm going to use the little dot symbol for multiplication, but you could use the X, you can use parentheses, whatever you'd like. And the height is this straight up and down vertical line, which is 3. And then we just multiply. Area equals 8 times 3 is 24. Now in this example, they did give us units. They told us we have inches here. So I'm going to write inches, but remember, those are square units even though I don't see them. All area is in square units. And that is my final answer. So we'll do another parallelogram. Again, write out the formula. Area equals base times height. Area equals, the base this time is not along the bottom, it just happens to be along the top. That's fine. Times the straight up and down height is 12. And 5 times 12 is 60. The unit given to us is centimeters. Put the squared on there. And there's our answer. I'll do one example of a rhombus with it because a rhombus has the same formula. A rhombus is just a special type of parallelogram, so we can use the same formula. So area equals base times height. Area equals, our base here is 3. Our height is 2.5. I'm choosing to use parentheses this time only because I have a decimal. I don't want to put like a dot with a dot, but you totally could. Okay, and then in your calculator, when you type in 3 times 2.5, you get 7.5. And the unit given to us are feet, and we put squared. So same area formula for the two different shapes. Substitute and write your units. So the next section is a section for you to do on your own. You can pause the video right now and do it now, or you can opt to keep going and do all the on your owns at the very end. So I'm going to move on. You can pause it here if you'd like. So our next shape is going to be a rectangle. Rectangle, it's similar to base times height. We just don't call it base times height. We call them length and width. So I'm going to write out my formula. Area equals length times width. Remember, that means multiplication. They're shoved up against each other. It doesn't matter which one you call which. I usually call this one length and this one width, but it just doesn't matter. So 4 times 11, and we get 44 meters squared. Let's do another rectangle. Area equals length times width. All right, I'll say the length is 10 and the width is 2. 10 times 2. And we get 20 square yards. On to squares. So with squares, a square is a type of rectangle, just that it has all sides the same. So if you wanted, you could use length times width. However, eventually you want to get into knowing side squared, because that is more popular in high school and going to get used more often. But you're always welcome to fall back on this if you don't remember this one, okay? I'm going to use side squared. So area equals the side squared. They only need to give us one side because they're all the same. So I'll plug in 7, and we're going to square that. Now remember, 7 squared means 7 getting multiplied twice. It means 7 times 7. It does not mean 7 times 2, okay? We get 49. We do not get 14. That's like the biggest mistake I see all the time. Unit they gave us was centimeters, still squaring that unit. One more of those. Area equals side squared. Our side is 3. It's going to get squared. Again, this means 3 times 3. It does not mean 3 times 2. 3 times 3 is 9 inches squared. All right, that's it for rectangles and squares. Again, this is the section to do on your own to practice. You can pause the video now and practice on your own, or save them all till the end. I'm going to keep moving on. Our next shape are triangles. Triangle is 1/2 times the base times the height. So I'm going to write that out. 1/2 base times height. Going to bring down my 1/2. That's always going to be there to start the problem. My base, again, usually along the bottom, is 8. The vertical height is 3. This is all getting multiplied together. So 1/2 times 8 times 3. Now, a lot of us do not like fractions. Luckily, it's just 1/2. It's a nice fraction. So the trick here, I like to get rid of the fraction right away. You can take 1/2 of 8. You could take 1/2 of 3. Or you can do 8 times 3 and then take 1/2. I like to do the 1/2 first. 1/2 of 8 comes out nice. 1/2 of 3 doesn't. So I'm going to do 1/2 of 8 and get 4. And I haven't used the 3 yet, so I'm going to bring down the times 3. And then we simply just do 4 times 3 and get 12. Units given are inches squared. So it's not too bad to get rid of the fraction. We'll do another one like that. Area equals 1/2 base times height. Area equals 1/2. Base here is 13. Now I have this like nice right triangle. The height's actually along the edge here. Again, it's a vertical dimension. So 1/2 times the base is 13 times the height is 4. Again, I'm going to make a decision about which number I want to take 1/2 of. 1/2 of 13 is a decimal. I don't like it. 1/2 of 4 though is pretty. It's a 2. So 1/2 of 4 is 2. I haven't used the 13 yet, so I'll bring that down. And then 2 times 13 is 26, and the unit is millimeters squared. Our last triangle example is an obtuse triangle. I've actually given you one of each of these. You have an acute triangle, a right triangle, and an obtuse triangle. What's weird about the obtuse triangle is you'll see the height kind of like along like a dotted edge, showing you the height of that triangle. This is the base, this is the height. All right, formula first, 1/2 base times height, 1/2 times the base is 7 times the height is 6. I'm going to do this last one different just to show you your options. What I normally would have done, I don't like 1/2 of 7, but I do like 1/2 of 6. I would have done that and then multiply by 7 after. But in case you don't want to do that method, you can keep the 1/2 and you can multiply the other two numbers first if you'd like. 7 times 6 is 42. And then you can take 1/2 of 42, which is 21. Some people like it that way. The only reason I don't is because I get a bigger number to take 1/2 of. It just gets a little bit more challenging, but it's totally up to you. Okay. Again, this is a your turn section for you to practice on your own. You can pause the video here. Notice in number 2 real quick, they don't give you any units. You're just going to write the word units again, like units squared. Okay, so you can pause here or leave it for the end. I'm going to move on to the last page. All right, our last shape is the trapezoid. Last because it also has the most difficult formula. You can see there's the 1/2, kind of like the triangle. I have a height. I have some bases here. I have a base 1 and a base 2. And just as a heads up, these are not exponents. This is just saying my first base and my second base. Okay? So I'm going to write out this long formula. 1/2 height, base 1 plus base 2. A equals, bring down that 1/2. All right, let's go through what these dimensions are. Height, remember, straight up and down vertical. So that's going to be the 6 because it's going right up and down. The bases are these two numbers here. It doesn't matter which one we call which. I'll call base 1 the 10 and I'll call base 2 the 12. And now we substitute. So next is h, which is a 6. Again, it's up against it, so it's getting multiplied together. Start up a parenthesis. Now it wants base 1, which we labeled as 10, plus base 2, which we labeled as 12. Close the parentheses. All right, now we can't forget order of operations here, okay? So think back to PEMDAS, P standing for parentheses. So we can do the parentheses first. We can also do this multiplication right away. I'm kind of going to take care of 2 steps at once. So 1/2 of 6 is 3. And again, it's right up against these parentheses, so they're going to get multiplied together. 10 plus 12 is 22. And lastly, 3 times 22 is 66 feet squared. All right, let's do another one of those. Area equals 1/2 height, base 1 plus base 2. Area equals, bring down the 1/2. We're going to be multiplying. All right, let's label our dimensions. Height straight up and down, that's the 5. Bases, doesn't matter which one you call which. I'll call this one base 1 and this one base 2. So in for height is going 5. Parentheses, my first base is 13 and my second base is 7. All right, this one's a little bit trickier. Parentheses first, right? I can do that, but you can see I can't really cheat and do this step right now. I could if I wanted to, but 1/2 of 5 is not very nice. So I'm actually going to save that. You could do it, but I just want to show you some other options for evaluating this. So I'm going to leave the 1/2 of 5 because it doesn't come out pretty. We'll do that 13 plus 7 and we get 20. Now, just like the triangle, I can pick whichever number I want to take 1/2 of. I don't want to do 1/2 of 5, but 1/2 of 20 is nice. 1/2 of 20 is 10. Bring down the 5 I haven't used. And 10 times 5 is 50 square meters. All right, you have 3 trapezoids to try on your own. You can pause the video now and do it, or save it till the end. I'm moving on to the very last section, which is working backwards here. This time we're going to be given areas, and we have to find the missing dimension. To do this, you're going to have to look back on these pages for those area formulas unless you have them memorized, okay? So in the first picture, you have to know the shape. This is a parallelogram. I have to go back to that parallelogram page and find the area formula. The area formula for parallelogram was nice and easy. It was just base times height. All right, now we're gonna substitute. So let's take a look. Next to the letter A, it tells us the area. So this is the very first time we're gonna plug a number in for that capital A. So in for that capital A goes 36. Bring down my equal sign. The base. If I go to the picture, the base in this picture is 9. Times. The height that's straight up and down, ooh, it has a question mark. That's what we're looking for. We don't know the height. I'm gonna leave it as H. So at this point, we actually have an equation that we need to solve. When we solve equations, we gotta remember opposites. So it's 9 times H. The opposite of multiplying is to divide. So we're gonna divide both sides by 9. Goodbye to these 9s. The height is left. 36 divided by 9 is 4. Now notice my unit. It says feet in the problem, but this time we're not going to put squared on it because it's not an area, it's a height. The area was plugged in for, so we're actually just going to leave it. The height is 4 feet. Okay, we'll do one more of those missing dimensions together. Our new shape is a triangle. Again, we're going to have to go back to the triangle page and find the formula. It was area equals 1/2 base times height. The area, it tells us up here that the area is 20. So that goes in for the capital A. Bring down the 1/2 times the base. Oh, here's the base. We don't know it, so I'm going to leave it as the letter B. Times the height is given to us, that's 8. Remember, I can take half of whatever I'd like on that side of the equation. I can't do half of B because I don't know what B is, but I do know what half of 8 is, which is 4. Bring down the times B. And now we're back to an equation. Opposite of multiplying is to divide. Do it to both sides. And the base is 5. Unit is inches. It's not area, it's just the base, so we're not going to put that little exponent on it. And the last one is for you to try on your own. You have a rectangle, and you can go look up the rectangle formula, substitute, and solve the equation. And that is it for area.